Oops. We'll start in 1 minute. We'll spend this week reviewing for the final exam. The final exam will be on Monday, May 4th. The regular schedule for that is from 3 p.m. to 5 p.m. But there will be more information about that, and I'll give that to you when I find out what that is. Since the final exam will be taken on Newton, it's pretty important that you do the final exam practice on Newton. You can take it up to 5 times. Okay, we'll start with the review. We'll just go over problems that you'll see on the final. Okay, the first one, solve this absolute value inequality. The absolute value of 5x minus 8 is less than 6. And then write the solution in interval notation. Just like with all inequalities, we want to find endpoints. For algebraic inequalities, the endpoints are the solutions to the absolute value equation. In this case, the absolute value of 5x minus 8 equals 6. The two solutions to this will be the two endpoints. So if the absolute value of 5x minus 8 equals 6, then 5x minus 8 could be 6, or 5x minus 8 could be negative 6. We'll solve each of those two equations. The solutions will be the endpoints. So on this one, add 8 to both sides. We get 5x equals 14. Then divide both sides by 5, x equals 14/5. So that's one of the endpoints. On the other one, add 8 to both sides. Negative 6 plus 8 is positive 2. Then divide both sides by 5, x equals 2/5. That's the other endpoint. So we plot those numbers on the number line. 2/5 is to the left of 14/5. And we have 3 intervals to test. In the first interval, we can pick x to be 0. And then in the inequality, replace x with 0. So 5 times 0 is 0. 0 minus 8 is negative 8. But the absolute value of negative 8, which is equal to 8, less than 6, is false. So none of the numbers from negative infinity to 2/5 are solutions. In the second interval, we can pick x to be positive 1. And then in the inequality, replace x with 1. So the absolute value of 5 times 1 minus 8 is the absolute value of negative 3. And that's equal to 3. And 3 less than 6 is true. So all of the numbers between 2/5 and 14/5 are solutions. And then in the third interval, pick a number bigger than 14/5. 3 is a number bigger than 14/5. And then in the inequality, replace x with 3. 5 times 3 is 15. 15 minus 8 is 7. And the absolute value of 7 is 7. But the inequality, 7 less than 6, is false. So none of the numbers from 14/5 to infinity are solutions. And then since the inequality is strictly less than, the endpoints are not included. So graphically, we would put parentheses at the endpoints. And the interval notation is parenthesis 2/5, comma 14/5, parenthesis. Okay, and number 2, solve the absolute value equation. First, we want to add 5 to both sides so that the absolute value part is isolated. The absolute value of 6z minus 1 equals 4. And then if the absolute value of 6z minus 1 is 4, then 6z minus 1 could be 4, or 6z minus 1 could be negative 4. And then solve each of those equations. Add 1 to both sides, 6z equals 5. Then divide both sides by 6, z equals 5/6. That's one of the solutions. In the other one, add 1 to both sides, 6z equals negative 3. Then divide both sides by 6, z equals negative 1/2. Okay, so those are the 2 solutions to that absolute value equation. Okay, number 3, it says graph the line x equals negative 8. So in the xy plane, the x-axis is the horizontal axis, and the y-axis is the vertical axis. But the line x equals negative 8 is a vertical line. So I guess I shouldn't put a dash line. I should put a line with no dashes and then label it. This is x equals negative 8. The reason x equals negative 8 is the solution is because every point on this line has the same x coordinate of negative 8. Okay, and the next problem 4, graph the equation 4x minus 4y equals 12 using the intercepts. Okay, so we'll find the x-intercept and the y-intercept. First, find the x-intercept. Well, every x-intercept has a y-coordinate of 0. So in the equation, if you replace y with 0, we get 4x minus 4 times 0 equals 12, or 4x equals 12. And then solve that equation for x equals 3. So the x-intercept is the ordered pair 3, 0. Then to find the y-intercept, the x-coordinate of a y-intercept is 0. So this time in the equation, replace x with 0. 4 times 0 is 0. 0 minus 4y is negative 4y, and negative 4y equals 12. Now we divide both sides by negative 4, and the y-coordinate is negative 3. Okay, so we're graphing the line. We'll plot the x-intercept. So here's the x-intercept. Remember, the x-intercept is an ordered pair, so it's 3, 0 in parentheses. The y-intercept, 0, negative 3, is also an ordered pair, so parenthesis 0, negative 3, parenthesis. And then in order to graph a straight line, you just need 2 different points. So we have 2 points, and then draw a straight line through those points. So that's the graph of that line. Okay, on the next page, problem 5, find the slope of the line that passes through the points 4, 3, and negative 9, 0. So I'll remind you of the slope formula, the slope of a line M. If you have two different points, x1, y1, and x2, y2, the slope of the line that passes through those points is y2 minus y1 in the numerator, and then divided by x2 minus x1. Okay, so we can assign x1, y1 to be either of those 2 points. It doesn't matter. And then just pick the other one to be x2, y2. So the numerator, all right, 3 minus 0, that's the difference in the y coordinates. And then in the denominator, the difference of the x coordinates, 4 minus negative 9. 3 minus 0 is 3. 4 minus negative 9 is 4 plus 9. And so the slope is positive 3 over 13. Okay, number 6, use the slopes to determine if the lines y equals x divided by 3 plus 7 and negative 6x minus 2y equals 4 are perpendicular. This line, this first one, y equals x divided by 3, that is equivalent to writing y equals 1/3 times x and then plus 7. So the slope of this line is 1/3. And it's not immediately apparent what the slope of the other line is, but if we solve this other equation for y so that it's in the form y equals mx plus b, then we'll be able to tell what the slope is. So let's go ahead. I'll write negative 6x minus 2y equals 4, and we'll solve for y. So first add 6x to both sides, so we get negative 2y equals 6x plus 4. And then divide every term on both sides by negative 2, and we get y equals negative 3x minus 2. Okay, so the slope of the second line is negative 3. Since the two slopes are negative reciprocals, the lines are perpendicular. So we'll write the lines are perpendicular because the slopes are negative reciprocals. Okay, so just a couple more comments. The reciprocal of 1/3 is 3 over 1, or 3, and so the negative reciprocal of 1/3 is negative 3, which is what the slope of the other line is. So that means the lines are perpendicular. Okay, in the next problem, simplify the expressions using properties of exponents. So the way I'm going to start, I'm going to simplify what's inside the set of each parentheses first, and then afterwards we'll apply the outer exponents. So inside this first set of parentheses, I have 4 divided by 3. That can't be simplified any further. But then c to the third divided by c to the fifth, that simplifies to c to the second in the denominator. And then d to the ninth divided by d to the second simplifies to d to the seventh in the numerator. In the other set of parentheses, the coefficients are 2 divided by 6. 2 divided by 6 simplifies to 1 divided by 3. The numerator has one factor of c in it, but the denominator doesn't have any factors of c, so there's one factor of c in the numerator. And then d to the third divided by d to the fourth is one factor of d in the denominator. Okay, the next step, we'll apply the outer exponent on this term. So this means we're going to raise 4 to the second. And then d to the 2 times 7 is d to the 14th. And then we also apply the outer exponent 2 to the factors in the denominator. So it's going to be 3 to the second times c to the 4th, because 2 times 2 is 4. Okay, the next step over here, since this has an outer exponent of -2, what we can do is write the reciprocal of the fraction. In other words, 3d over c, and change this outer exponent to +2. Okay, we'll simplify this a little bit. 4 to the second is 16, so I get 16 times d to the 14th divided by 9c to the 4th, because 3 to the second is 9, so 9c to the 4th. And then we can square 3d. We're raising it to the second power, so 3d times 3d is 9d to the second. And then in the denominator, c to the second. Okay, and we should be able to write the completely simplified expression in the next step. Notice that 9 divided by 9 cancels. And so we're just left with 16 d to the 14th times d to the second. So the numerator is 16 times d to the 16th, because we add the exponents on d when we multiply those. And in the denominator, c to the 4th times c to the second is c to the 6th. And that's as far as we can simplify that. Okay, the next problem, number 8. This is a work problem. Equations have the form rate times time equals 1. Okay, so we're told that Jerry can frame a room in 1 hour, and it takes Jake 4 hours to do the same job. So we'll start with Jerry. So Jerry works at a certain rate. I'll go ahead and write R sub Jerry, and in 1 hour, he can complete the job of framing a room. So rate times time equals 1. And for Jake works at his rate, and in 4 hours, he can complete the job. Rate times time equals 1. And they want us to figure out how long it would take them if they work together. So when they work together, we don't know the amount of time that takes yet. So Jerry's rate plus Jake's rate. So we'll pick a variable like t to represent the amount of time it takes them to do the job when they work together. Okay, so Jerry's rate is 1. 1 divided by 1 is 1. Jake's rate is 1/4. That just means that he can complete 1/4 of the job per hour. And then Jerry's rate plus Jake's rate is 1/t. Okay, then replace Jerry's rate with 1, so we get 1 plus Jake's rate, which is 1 plus 1/4, equals 1 over t. Okay, so the least common multiple of the denominators, or the least common denominator, is just 4t. And then we multiply every term on both sides of this equation by 4t. So 4t times 1 is 4t. 4t times 1/4 is t. And 4t times 1 over t, the t's canceled, so that's equal to 4. And then 5t equals 4. Divide both sides by 5, t equals 4/5 of an hour. So 4/5 of an hour is 48 minutes. But we'll just write the hours units, 4/5 of an hour. Okay, we have another couple of application problems. So if you're still struggling with these word problems, just try as hard as you can to understand them. This one says Josie owes $65,800 in student loans. The interest rate on the federal loans is 4.5%, and the rate on the private bank loans is 2%. The total interest owed for 1 year is $2,878.50. Find the amount of each loan. Okay, so we'll fill in a few details that are a little bit sparse. Josie took out 2 different loans, and the total for the 2 loans is $65,800. One of the loans was a federal loan with an annual interest rate of 4.5%, and the other loan was from a private bank, which has an annual interest rate of 2%. And then after 1 year, the total amount of interest earned was $2,878.50. So find the amount of each loan. So we can pick a variable x to be the loan whose annual interest rate is 4.5%. So loan at 4.5% per year. That's the implication. And then we'll pick y to be the loan that's at 2% per year. So this is the amount of the loan at 2% per year. Okay, so based upon the variable assignments, we can write 2 equations. So x plus y is the total amount of money in both loans. So x plus y equals 65,800. That's one equation. And then in the other equation, every term represents a certain amount of interest. So if x dollars is charged 4.5% interest per year, then after 1 year, the amount is 0.045 times x. We add that to the interest on y dollars. If it's 2% per year, after 1 year, it's 0.02 times y. And then we're told that the total amount of interest on both accounts after 1 year was $2,878.50. So we want to solve this system of two equations using one of our methods. We can use substitution or the addition method, the elimination method. So if you want to use substitution, we can solve the top equation for y equals 65,800 minus x. I just subtracted x from both sides. And then in the other equation, replace y with 65,800 minus x. Then we'll have an equation whose only variable is x. And then we'll be able to solve that for x. So 0.02, I'm going to replace y with 65,800 minus x, and that's equal to $2,878.50. So now we just have to be careful with arithmetic. So I'll rewrite this term, 0.045x. And when I add 0.02 times 65,800, that's that first product, 0.02 times 65,800, is just 1,316. And then we subtract 0.02x equals $2,878.50. Okay, so in the next step, I'll do two things. I'll combine the like terms, 0.045x minus 0.02x. That's just going to be positive 0.025x. And I'm also going to subtract 1,316 from both sides. And when I subtract 1,316, I'm going to be left with 1,562.50. Okay, then you can divide both sides using a calculator by 0.025. So 1562.50 divided by 0.025. And that's going to be $62,500. Okay, then to find y, just replace up here. Just replace x with 62,500, and the y value is just 3,000. Wait, 3,300. Okay, that wasn't so bad. Okay, and the next example, number 10, this one says 150 milliliters of a 15% acid solution is needed. Find the number of milliliters of a 10% solution and the number of milliliters of a 25% solution that should be used to make the 15% solution. Okay, so if we pick x to be the number of milliliters of the 10% solution, and then if we pick y to be the number of milliliters of the 25% solution, those two are going to be combined for a total of 150 liters. That's 15% acid. Okay, so our first equation, we just add X milliliters plus Y milliliters, and that has to equal 150. And then the mixture is going to be 15% acid. But in the X liters, if the X liters is 10% acid, then the amount of acid is 0.10 times X. And if Y liters is 25% acid, then the amount of acid is, in that amount, is 0.25 times Y. Okay, and then the mixture of 150 liters has to be 15% acid. So we're going to multiply 0.15 times 150. Okay, so there is our system of two equations. So if you want to use the elimination method, well, one of the things you could do, there's more than one way to apply the elimination method, but I'm going to multiply every term on both sides of the top equation by negative 0.10. So multiply by negative 0.10. And then I'll just put it below this second equation. So I'll get negative 0.10x minus 0.10y. And then 150 times negative 0.1y is just negative 15. Okay, and then when I add these two equations, the variable x will be eliminated. 0.25y plus negative 0.10y is positive 0.15y. And here, well, note that 0.15 times 150 is just 22.5. And so when I add 22.5 to negative 15, I just get positive 7.5. And then to solve for y, we can just divide both sides by 0.15. So 7.5 divided by 0.15. We can think of that as 750 divided by 15. And that simplifies to 50. So the number of milliliters that's 25% solution is 50 milliliters. And since the x plus y adds up to 150, I replace y with 50, x is equal to 100 milliliters. Yeah, that's not too bad. Often in these problems, the numbers work out pretty nicely like that. Okay. Now we'll look at factoring. Factor 6d to the second plus 29d plus 28. The greatest common factor of all three terms is 1. So let's try the AC method. So So the first step in the AC method, multiply 6 times 28. So that's 168. And we want to see if we can find two integers that have a product of 168 and a sum of 29. Okay, so the systematic method, if you start at the extremes, 1 times 168, those add up to 169. 2 times 84, then 3 times 56, 4 times 42, 5 is not a factor, 6 times 28, those add up to 34, we're getting closer, and then 7 times, let's see, 24, yeah, that's right. Those add up to 31. And then 8 times 21, those add up to 28. So that means we can factor using integer coefficients. So in the next step, we transform the trinomial into a quadrinomial using those two numbers, 8 and 21. We replace plus 29d with plus 8d plus 21d. And then we factor by grouping. Out of the first two terms, the greatest common factor is 2 times d. And then we're left with the binomial 3d plus 4. Then bring down the middle operator of addition. Out of the third and fourth terms, 21d plus 28, we can factor out 7. And the binomial left behind is 3d plus 4. And then the last step, factor 3d plus 4 out of both terms, and the other binomial is 2d plus 7. You can always check that your factors are correct by multiplying. Okay, the next problem, factor 192 p to the second q minus 144 p q to the second plus 27 q to the third. First, we look at the numerical coefficients. The greatest common factor of the coefficients is 3. 3 divides evenly into those coefficients. And then there's also a common factor of q. So we can factor 3 times q out of every term. And if you divide this first term, 192 p to the second by times q, if you divide that by 3q, you're left with 64 p to the second. And then when you divide negative 144 p q to the second by 3q, you're going to be left with minus 48 pq. And then factor 3q out of 27q to the third, you're left with 9q to the second. That's supposed to be a 9, not a q. 9 times q to the second. Okay, now the question is, can we factor further? Well, notice inside the parentheses, this trinomial inside the parentheses, this first term, 84 or 64 p to the second, is a perfect square. If you square the term 8p, you get 64 p to the second. And the term on the right is also a perfect square. If you square the term 3q, you get 9q to the second. And then the middle term is the same as minus 2 times 8p times 3q. So this is a perfect square trinomial. Its two factors are identical. So one factor is 8p minus 3q. The other factor is identical to that, 8p minus 3q. You can verify by multiplying that those two factors are the factors of that perfect square trinomial. Okay, the next problem, use the discriminant to determine the number of solutions to the quadratic equation. Okay, so A is negative 45, B is positive 4, and C is negative 1. Remember, the discriminant is b to the second minus 4ac. And if you know what the discriminant is, then you know what kind of solutions you have. So b to the second minus 4ac is 4 to the second minus 4 times negative 45 times negative 1. And then we'll do the arithmetic. So 4 to the second is 16. And we're subtracting 4 times negative 45 times negative 1. Negative 45 times negative 1 is positive 45. So we're subtracting 4 times 45, which is minus 180. And 16 minus 180 is negative 164. Okay, since the discriminant is negative, that means we have 2 non-real solutions. We have 0 real solutions because the discriminant, that's the number inside the square root. Okay, in the next example, simplify the cubed roots. 9 times the cubed root of 184 z to the 12th minus 8 times the cubed root of 621 z to the 12th. We recognize z to the 12th as a perfect cube because the exponent 12 is a multiple of the index 3. And now we have to figure out if the cubed root of 184 can be simplified. Okay, so if we remember what the perfect cubes are, 8 is a perfect cube, and 8 is a factor of 184. 8 times, note that 8 times 23 is 184. And then the other one, this 621. So I think 23 goes into that. Let me see. 23 goes into 621. Yeah, it goes 27 times. Yeah, so and 27 is a perfect cube. So this is 27 times 23 equals 621. Okay, so now we can proceed to simplify. We have 9. We'll write 9 times the cubed root of the perfect cubes. So in this first one, it's 8 times z to the 12th multiplied by the cubed root of the remaining factor 23. And then minus 8 times the cubed root of the perfect cubes, 27 z to the 12th times the cubed root of 23. Okay, then in the next step, the cubed root of 8 is 2. The cubed root of z to the 12th is z to the 4th, because 12 divided by 3 is 4, times the cubed root of 23. And then minus 8 times the cubed root of 27 is 3. The cubed root of z to the 12th is z to the 4th. And then times the cubed root of 23. Okay, we can see that the two terms are going to be like terms. They both have the cubed root of 23 in it, and they both have z to the 4th. So let's just do the next step all at once. 9 times 2 is 18 for the coefficient on the left, and minus 8 times 4 is minus 24. 18 minus 24 is negative 6. So our simplified answer is negative 6 z to the 4th times the cubed root of 23. And don't forget the index 3. Okay, we'll move on to the next problem. Number 15, solve the rational inequality and write the solution in integral notation. Well, for a rational inequality, we want one side to be 0. So I'll subtract 1 over x from both sides. We get 1/2 minus 4 over x squared minus 1 over x is less than or equal to 0. And then we want to write the left-hand side as a single rational expression. So we need a common denominator. So the least common denominator is just 2x to the second. So for 1/2, if I just multiply the numerator by x squared and the denominator by x squared, I'll get 2x squared for the denominator. For the next term, the minus 4 over x squared, if I just multiply the numerator by 2 and the denominator by 2, I'll have a common denominator, or I'll have the common denominator, 2x squared. And then 1 over x, if I multiply the numerator by 2x and the denominator by 2x, then I'll have the denominator 2x squared. Okay, now we can write it as a single rational expression because the denominators are all the same. So I'm going to have x squared minus 2x and a minus 8. Okay, now we need to find the endpoints. The endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. We can see from the denominator that when x is 0, the denominator is 0. So one of the endpoints is 0. And we can factor the numerator. The numerator, the two factors are x minus 4 and x plus 2. And so the endpoints of 4 is one of the x values that makes the numerator 0. Negative 2 is an x value that makes the numerator 0. And then x equals 0 is the x value that makes the denominator 0. So we solve this inequality. We plot the endpoints, -2, 0, and 4. So we have 4 intervals to test. Okay, and we're under a minute left, so tomorrow we'll pick up with this number 15. We're a little bit more than 1/3 of the way through this final exam review. So we'll be able to finish this by Wednesday probably, and then we can look at some other things to review for the final. But that's all for today. We'll start in about a minute. Today we'll start reviewing for the final exam. The regularly scheduled final exam is on Monday, May 4th, from 3 p.m. to 5 p.m. But there will be some more information about the final exam that will be coming out, and I'll get that to you when I know it. Since you're going to take the final exam on Newton, make sure that you take the final exam practice on Newton. You can take it up to 5 times on Newton. Okay, we'll start the review. So this first problem, solve the absolute value inequality, and then write the solution in interval notation. Well, when solving algebraic inequalities, we need to find the endpoints. And the way that we find the endpoints for an absolute value inequality is to solve the absolute value equation, the absolute value of 5x minus 8 equals 6. The solutions to this absolute value equation are the endpoints that divide the number line into separate intervals. If the absolute value of 5x minus 8 equals 6, then 5x minus 8 could be 6, or 5x minus 8 could be negative 6. And then we'll solve each of those. Add 8 to both sides. 5x equals 14, and then divide both sides by 5, x equals 14 fifths. That's one of the endpoints. Solve the other equation for x. When we add 8, we get 5x equals 2. Then divide both sides by 5, we get x equals 2 fifths. So those are the two endpoints. So on the number line, we plot 2 fifths to the left of 14 fifths. Okay, in the first interval, we can pick x to be 0 in that interval. And then in the inequality, when you replace x with 0, 5 times 0 is 0, and the absolute value of negative 8 is 8, but the inequality 8 less than 6 is false. So none of the numbers from negative infinity to 2 fifths are solutions. In the second interval, we can pick x to be positive 1. And then in the inequality, replace x with 1. So the absolute value of 5 times 1 minus 8, that's the absolute value of negative 3, which is 3. And the inequality 3 less than 6, that's true. So all of the numbers between 2 fifths and 14 fifths are solutions. And then in the third interval, we can pick x to be 3. And then in the inequality, replace x with 3. 5 times 3 is 15. 15 minus 8 is 7. And the absolute value of 7 less than 6 is false. So none of the numbers from 14 fifths to infinity are solutions. And then since the inequality is strictly less than, the endpoints are excluded. So graphically, you would put a parenthesis at the endpoints. And then this is just calling for the interval notation for the solution. So the interval notation for the solution is parenthesis 2 fifths, comma 14 fifths, parenthesis. Okay, problem number 2, we're solving an absolute value equation on this one. First, we want to add 5 to both sides, so we get the absolute value of 6z minus 1 equals 4. And if the absolute value of 6z minus 1 is equal to 4, then one possibility is that 6z minus 1 is equal to 4. The other possibility is that 6z minus 1 could be negative 4. And then solve each one of those. Add 1 to both sides. We get 6z equals 5. And then divide both sides by 6. Z equals 5/6. And then for the other one, add 1 to both sides. 6z equals negative 3. Then divide both sides by 6. We get z equals negative 1/2. Okay, so those are the two solutions. In number 3, it says graph the line x equals negative 8. Okay, so in the xy plane, the line x equals negative 8 is a vertical line. So x equals negative 8 is the equation of this vertical line because every x coordinate is negative 8. Okay, so that's all there is to that one. Number 4, graph the equation 4x minus 4y equals 12 using the intercepts. So that means to find the x-intercept and the y-intercept. Let's find the x-intercept first. Every x-intercept has a y-coordinate that's equal to 0. So in the equation, replace y with 0, and we're just left with 4x equals 12, and then solve for x equals 3. Okay, so the ordered pair 3, 0 is the x-intercept. And then the y-intercept, every y-intercept has an x-coordinate that's 0. So in this equation, replace x with 0, and we're left with negative 4y equals 12. Divide both sides by negative 4, y equals negative 3. Okay, so the y-intercept is the ordered pair 0, negative 3. And in order to graph a straight line, we just need 2 points. So we'll plot those 2 points. 3, 0. So it's an ordered pair. Ordered pairs should have parentheses around them. So 3, 0 is the x-intercept, and then the y-intercept is this point, whose coordinates are 0, negative 3. And then if you have 2 points, you can draw a straight line through those 2 points to graph the equation. Okay, on the next page, we find the slope of the line that passes through the points 4, 3, and negative 9, 0. The slope formula for the slope of a line that passes through the points x1, y1, and x2, y2, the slope m is equal to y2 minus y1 divided by x2 minus x1. You can pick one or the other to be the x1, y1, and the other to be x2, y2. It doesn't matter which one you pick to be which. So I'll just start with 3 minus 0 in the numerator. And then I have to pick 4 minus negative 9 for the denominator. And then do the arithmetic. 3 minus 0 is 3. 4 minus negative 9 is 4 plus 9. And so the slope of the line is 3/13. Okay, on the next problem, number 6, use slopes to determine if the lines y equals x divided by 3 plus 7 and negative 6x minus 2y equals 4 are perpendicular. This equation, y equals x divided by 3 plus 7, that's equivalent to y equals 1/3 times x plus 7. So this is in slope-intercept form. The slope is positive 1/3. And we can determine what the slope of the other line is if we rewrite it so that it's in the slope-intercept form, the y equals mx plus b. So I'll rewrite this equation and then we'll solve for y. So we can add 6x to both sides. Negative 2y equals 6x plus 4. And then divide both sides by negative 2. 6x divided by negative 2 is negative 3x. And 4 divided by negative 2 is negative 2. So the slope of this line is negative 3. And the slopes are negative reciprocals, so that means the lines are perpendicular. The negative reciprocal of 1/3 is negative 3/1, or just negative 3, and vice versa. So the lines are perpendicular, which means when they intersect, they form right angles. Okay, in the next problem, we're going to simplify this expression by applying properties of exponents. So what I'm going to do, I'm going to simplify on each set of parentheses first, and then after that we'll take it to the next level. Okay, and inside this set of parentheses, looking at the numerical coefficients, 4 divided by 3, those cannot be simplified further, so 4 divided by 3. And then the variable c, we have c to the 3rd in the numerator and c to the 5th in the denominator, and that simplifies to c to the 2nd in the denominator. And then d to the 9th divided by d to the 2nd, that simplifies to d to the 7th in the numerator. Okay, the other set of parentheses, the numerical coefficients, 2 divided by 6, that simplifies to 1 divided by 3. The numerator has a factor of c in it, but the denominator doesn't have any factors of c, so there's still one factor of c in the numerator. And then the other variable, d to the 3rd in the numerator, d to the 4th in the denominator, that simplifies to d in the denominator. Okay, the next step, for the term on the left, we'll apply this outer exponent. Remember that 4 is equivalent to 4 to the 1st, and 3 is equivalent to 3 to the 1st. So we're going to multiply the outer exponent 2 times each of those 4 exponents, and we'll get 4 to the 2nd times d to the 14th, because 2 times 7 is 14. And then in the denominator, we get 3 to the 2nd times c to the 4th, because 2 times 2 is 4. And in the next term, since the outer exponent is negative 2, we'll write the reciprocal of this quotient. So 3d goes in the numerator and 1c, or c, in the denominator, and then the outer exponent becomes positive 2. Okay, we'll simplify a little bit over here on the left. 4 to the 2nd is 16 times d to the 14th divided by 9c to the fourth. And now we'll apply the outer exponent 2. In other words, we're just going to square the quotient. When you square 3d in the numerator, we get 9d to the second. And when we square c, we get c to the second in the denominator. Okay, notice in this product, we have a factor of 9 in the numerator that cancels with this factor of 9 in the denominator. And then the next step, we can write the completely simplified form. So over here in the numerator, 16 times d to the 14th times d to the second is 16 times d to the 16th, because we're adding the exponents. And in the denominator, c to the fourth times c to the second is c to the sixth. Okay, that's as far as we can simplify that one. Okay, the next problem, Jerry can frame a room in 1 hour while Jake takes 4 hours. How long would it take for them to frame a room working together? Okay, so we're told how long it takes Jerry if he works by himself, and also how long it would take Jake if he worked by himself, and we're supposed to find how long it takes them when they work together. Okay, so Jerry works at a certain rate, and in 1 hour he can complete the job of framing a room. So we have rate times time equals 1 for Jerry. Jake takes 4 hours, so Jake's rate times 4 hours equals 1. And we're supposed to find how long it takes them when they work together. So when they work together, it's Jerry's rate plus Jake's rate. And we'll pick a letter to represent the amount of time it takes them when they work together. So I'll pick capital T. So now we have 3 equations, each having the form rate times time equals 1. So we solve each of the equations for the rates. Jerry's rate is 1, which means that he can frame one room per hour. Jake's rate is 1/4, which means that he can frame 1/4 of a room per hour. And then when they work together, the rate is 1/t, and we have to solve for t. Okay, so in this equation, replace Jerry's rate with 1. We're adding that to Jake's rate, which is 1/4. And the sum of the 2 rates is 1/t. The least common multiple of the denominators is 4 times t. And so we just multiply each of those terms on both sides by 4t. 4t times 1 is 4t. Plus 4t times 1/4, the 4's cancel, so it's just plus t. And on the right-hand side, 4t times 1/t, the t's cancel, and we're just left with 4. And then 4t plus t is 5t. 5t equals 4. And when they work together, they can frame one room in 4/5 of an hour. 4/5 of an hour is equivalent to 48 minutes, but we'll just leave the units in hours. Here we have a couple more word problems. So this one says Josie owes $65,800 in student loans. The interest rate on the federal loans is 4.5%, and the rate on the private bank loans is 2%. The total interest she owed for 1 year was $2,878.50. So find the amount of each loan. Okay, so just to fill in a little bit, Josie has two loans. One is a federal loan. The annual interest rate is 4.5%. And then she has a second loan from a private bank, and its annual interest rate is 2%. And the total amount of interest after 1 year is $2,878.50. Okay, so we'll pick a variable X to be the loan, the amount of the loan at 4.5% per year. So I'll just write loan at 4.5%. X represents the number of dollars for that loan. And Y is going to represent the number of dollars of the loan at the other interest rate, which is 2%. Okay, so the total amount of the loans is $65,800. So that means one of our equations is X plus Y equals $65,800. And then in the second equation, each term will represent a certain amount of interest after 1 year. So X dollars at an annual interest rate of 4.5% per year. After 1 year, the interest is 0.045 times X. We're adding that to the amount of interest that Y dollars has if it's 2% per year. After 1 year, it's 0.02Y. And we're told that the total amount of interest after 1 year is $2,878.50. Okay, we can solve this equation using the addition method or the substitution method. The addition method is also called the elimination method. For this example, I'll just use substitution. I'll solve the top equation for Y by subtracting X from both sides. So Y is equal to 65,800 minus X. And then in the other equation, we'll replace Y with 65,800 minus X, and we'll get 0.045X plus 0.02 times this quantity, 65,800 minus X, and that's equal to $2,878.50. So we'll just solve this equation for X. So 0.045X, and then we multiply 0.02 times 65,800. That's just going to be 1,316, and then minus 0.02X equals $2,878.50. In the next step, we'll combine the like terms on the left-hand side, and I'll also subtract 1,316 from both sides. So 0.045X minus 0.02X, that's positive 0.025X. And then $2,878.50 minus $1,316 is going to be $1,562.50. And then we can divide both sides by 0.025, and so we get 1562.50 divided by 0.025. So key that into a scientific calculator. So 1562.5. Okay, so I get 62,500. So this is the amount invested, or this is the amount of the loan at 4.5% per year. And then Y is 65,800 minus 62,300, which is 3,300. Hey, that wasn't too bad. The next problem, 150 milliliters of a 15% acid solution is needed. Find the number of milliliters of a 10% solution and the number of milliliters of a 25% solution that should be used to make a 15% solution. Okay, so we're going to take a certain number of liters that is 10% acid. So I'll pick X to be the liters of the 10% acid solution. And then I'll pick Y to be the number of liters of the 25% acid solution. Okay, so we're going to mix those two amounts, X and Y, to get a total of 150 milliliters. That is 15% acid. Okay, so our first equation is just X liters plus Y liters equals 150 liters. And then the next equation will involve the percentages. So if X liters is 10% acid, then the amount of acid is zero in that X liters is 0.10 times X. And then we're adding that to 0.25 times Y. And then the mixture is 15% acid, so we have to multiply 0.15 times 150. And if you want, you can multiply 0.15 times 150. That's just going to be 22.5. Okay, so we want to solve this system of two equations. This time I'll use the elimination method. So I'm going to multiply every term on both sides of the top equation by negative 0.10. So I'll just make a note of that, multiply by negative 0.10, every term on both sides. And then I'll put the result below this equation. So we get negative 0.10x minus 0.10y. And 150 times negative 0.10 is just negative 15. Okay, so we'll add these two equations together. 0.10x plus negative 0.10x, this adds up to 0. And then in the next column, 0.25y plus negative 0.10y is positive 0.15y. And then 22.5 plus negative 15 is positive 7.5. And then we can divide both sides by 0.15. So 7.5 divided by 0.15. This is equivalent to 750 divided by 15. And 15 goes into 75 5 times. So this is 50. So the Y value is 50. Oh, I mislabeled those. Those aren't liters, those are milliliters. Sorry about that. So 50 milliliters, that's 25% acid. And since X plus Y is 150, X is 100 milliliters. So X is 100 milliliters and Y is 50 milliliters. Okay, moving on to the next page. Okay, this one says factor 6d to the second plus 29d plus 28. So we'll try the AC method. So we multiply 6 times 28, and we get 168. So we want to see if we can find two integers that have a product of positive 168 and a sum of positive 29. If the integers exist, they both must be positive. So if we start at the extremes, 1 times 168, those add up to 169. Then 2 times 84, 3 times 56, 4 times 42, 5 is not a factor, 6 times 28, those add up to 34, we're getting closer. 7 is a factor, 7 times 24, so those add up to 31. And then 8 times 21, those add up to 29. So that means we can factor this with integer coefficients. So we transform the trinomial into a quadrinomial. We're going to replace the plus 29d with plus 8d plus 21d. And then we factor by grouping. Out of the first two terms, we can factor out 2 times d. And the binomial that stays behind is 3d plus 4. And then out of the third and fourth terms, the greatest common factor is 7. And the binomial 3d plus 4. Okay, then the complete factorization, 3d plus 4 times 2d plus 7. Okay, the next one, factor 192 p to the second q minus 144 p q to the second plus 27 q to the third. Each of the three terms has at least one factor of q, and each of the numerical coefficients is divisible by 3. So we can factor 3 times q out of every term. So let's see, 3 times, 64. So 64 p to the second. And 3 times negative 48 is negative 144. So the middle term will be minus 48 p times q. And then factor 3q out of 27 q to the third, we're left with 9q to the second. Okay, now we want to see if we can factor the trinomial. Notice that the first term in the trinomial is a perfect square. If you square the term 8p, you get 64p to the second. The term on the right is also a perfect square. So we should wonder if it's a perfect square trinomial. So the middle term, minus 48pq, if it's a perfect square, that should be equal to negative 2 times 8p times 3q. And sure enough, this checks out to be a perfect square trinomial. That means its two binomial factors are identical. So the first term in each binomial is the square root of 64p to the second, or 8p. Since the trinomial has minus plus, this should be minus. And then the square root of 9q to the second is 3q. Then if you're ever in doubt about your factoring, you can multiply the factors. Okay, number 13, use the discriminant to determine the number of solutions to the quadratic equation. Okay, so on this one, in this quadratic equation, the value of A is negative 45. The value of B is positive 4. And the value of C is negative 1. So remember, the discriminant is B to the second minus 4AC. When using the quadratic formula, the discriminant is the number that's inside the square root. So we can classify the solutions to any quadratic equation just by knowing what the discriminant is. So in this case, B to the second is 4 to the second, and then minus 4 times negative 45 times negative 1. 4 to the second is 16, and we're subtracting 4 times negative 45 times negative 1. Note that negative 45 times negative 1 is positive 45, and so it's minus 4 times 45, or minus 180, and the discriminant is negative 164. Okay, so since the discriminant is negative, the two solutions are two different non-real solutions. So two different non-real solutions. So the implication is that there are 0 real solutions. Okay, the next example, simplify 9 times the cubed root of 184z to the 12th minus 8 times the cubed root of 621 times z to the 12th. Well, z to the 12th is a perfect cube because the exponent 12 is a multiple of 3. And now we want to decide, or want to determine, if the cube root of 184 can be simplified. 8 is a factor of 184, and 8 is a perfect cube. 8 times 23 is 184. So we can rewrite that first term, 9 times the cubed root of 8z to the 12th multiplied by the cubed root of 23. And now we'll move over to the other term. So once again, we have z to the 12th, which is a perfect cube. And the largest factor of 621, that is a perfect cube, is 27. 27 times 23 is 621. So we can rewrite this second term as minus 8 times the cubed root of 27z to the 12th times the cubed root of 23. Okay, then in the next step, we have 9. We can simplify the cube root of 8z to the 12th. The cube root of 8 is 2, so it's 9 times 2 times z to the 4th. The cube root of z to the 12th is z to the 4th. Remember, divide the exponent 12 by the index 3, and then we multiply that by the cube root of 23. And then minus 8 times the next term. The cube root of 27 is 3, and the cube root of z to the 12th is z to the 4th. So we get minus 8 times 3 times z to the 4th times the cube root of 23. Okay, notice that all of the terms are like terms. They both have the same simplified cubed root of, which is the cubed root of 23. And both terms have, on the outside of the radical, they both have z to the fourth. So we can combine everything into a single term. So 9 times 2 is 18, so the coefficient of this one is 18, and the coefficient of this one is negative 24. So 18 minus 24 is negative 6. So negative 6 times z to the fourth times the cubed root of 23. This is the simplified result on that one. Okay, the next problem is a rational inequality. Solve the rational inequality and write the solution in interval notation. When solving rational inequalities, we want one side to be 0, and then we want the other side to be a single rational expression. So we have some intermediate work to do first. So first we'll subtract 1 over x from both sides. So we have 1/2 minus 4 over x squared minus 1 over x is less than or equal to 0. And the least common denominator is 2x squared. So that will help us write the left-hand side as a single rational expression with a common denominator of 2x squared. So note that 1 over 2, if I multiply the numerator and denominator by x squared, I get x squared over 2x squared. So now I have the common denominator, 2x squared. For the next term, minus 4 over x squared, if I multiply the numerator by 2 and the denominator by 2, I get minus 8 over 2x squared. And then for the next term, 1 over x, if I multiply the numerator by 2x and the denominator by 2x, I'll have the common denominator 2x squared. And now that I have a least common denominator, I can write this as a single rational expression with a common denominator 2x squared. Okay, and in the numerator, we have x squared, and we have minus 2x, and we also have minus 8. Okay, now we can find the endpoints. The endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. We can tell by looking that when x is 0, the denominator is 0. So x equals 0 is one of the endpoints. And then we can also factor the numerator. Okay, so I'll rewrite this numerator in factored form. So it's x minus 4 times x plus 2. And the denominator is 2x to the second, and the inequality is less than or equal to 0. So the endpoints of the intervals, well, one x value that makes the numerator 0 is 4. Another value that makes x value that makes the numerator 0 is negative 2. And then the x value that makes the denominator 0 is 0. Okay, so we plot those endpoints. Negative 2 is to the left of 0, which is to the left of 4. And so we have 4 intervals to test. In the interval on the left, we can pick x to be negative 3. And then using this inequality where the numerator is factored is more convenient, I think. So replace every x with negative 3. Negative 3 minus 4 is negative 7. Negative 3 plus 2 is negative 1. And the denominator, 2 times the number negative 3 squared, is positive 18. So this number is positive 7/18. And the inequality is less than or equal to 0. So that's false. So that means none of the numbers from negative infinity to negative 2 are solutions. In the second interval, we can pick a number, we can pick x equals negative 1, because that's between negative 2 and 0. And then replace every x with negative 1. Negative 1 minus 4 is negative 5. Negative 1 plus 2 is positive 1. And 2 times the number negative 1 squared is 2. So this number is negative, and a number that's negative less than or equal to 0, that's true. So the numbers between negative 2 and 0 are solutions. In the third interval, I'll pick x to be 1, and then replace every x in the inequality with 1. 1 minus 4 is negative 3, times 1 plus 2 is times 3, divided by 2 times 1 to the second, or 2. So this number is negative. So less than or equal to 0, that's true. And then in the fourth interval, if we pick x to be 5, and then replace every x in the inequality with 5, 5 minus 4 is 1. 5 plus 2 is 7. And in the denominator, 2 times 5 squared is 50. So this number is positive, but a positive number less than or equal to 0 is false. Okay, so between 0 and 4, the answer is yes. And then from 4 to infinity, the answer is no. Okay, you might be surprised that 2 intervals next to each other are both part of the solution set, but that is because this x value that comes from the numerator is squared. Okay, but we're still going to exclude 0 itself because that comes from the numerator. We include the other endpoints because if you replace every x with the endpoints that come from the numerator, you get 0 less than or equal to 0, which is true. So we put a bracket at negative 2 and a parenthesis at 0, parenthesis at 0, and a bracket at 4. Okay, so the interval notation, we're excluding 0. So I'll write it up here. The interval notation is bracket negative 2 comma 0 parenthesis, and then union parenthesis 0 comma 4 bracket. Okay, the next problem is solving the system of equations. 3x plus 8y equals negative 3, and 2x plus 5y equals negative 3. We've seen a couple of examples. Well, the word problems, 2 of the word problems involve solving a system of linear equations. And we have 2 practical methods. One is the substitution method, and the other one is the elimination method. So if we use elimination on this one, you're not required to use that, but if we use elimination, we have options. So what I would do is I would focus on eliminating the variable x, And if I multiply every term on both sides of the top equation by 2, I'll get 6x plus 16y equals negative 6. And then multiply every term on both sides of the bottom equation by negative 3. I get negative 6x minus 15y equals positive 9. And then when we add these two equations together, the variable x will be eliminated. 16y plus negative 15y is y, and negative 6 plus 9 is 3. Okay, we're about out of time, so we'll finish this problem tomorrow, and we're over 1/3 of the way through this final exam review. So after that, we'll work on other things on Wednesday and Friday. But that's all for today.